In this lecture, we're going to have a look at game AI. It's going to be very much an introduction to artificial intelligence and mapping it onto the types of AI that we find within games. So we'll start off first of all really saying what game AI is and sort of comparing and contrasting it to artificial intelligence as a topic within computer science. There is a distinction between what you might define as academic artificial intelligence and the types of AI that you find within games. They overlap to some degree, but equally they also differ in other aspects. We just want to set this out by way of refining and defining exactly what it is we mean by game AI. So artificial intelligence, if we define it generally, it can be defined as aiming to develop machines that perform human thinking tasks. And academic research basically it splits into sort of two broad areas. There's not a lot of overlap between the two. You have approaches which are cognitively plausible. You call it sort of strong AI. That is where we try to create computing systems that in how they operate, they have an analogy or a mirror, or they somehow replicate the same types of thinking processes that the human brain goes through. So that covers all the way from sort of neural nets up in terms of systems which can be sort of described as being, physiologically, biologically plausible in terms of how they operate. A much bigger set of AI beyond that, known as weak AI, and that's simply concerned with problem solving and solving types of problems that we would require sort of a lot of thinking effort to do, getting machines to do it, irrespective of how they do it. It's more of the outcome and their ability to solve those problems, to perform the tasks that counts. What's under the surface doesn't really matter. For academic AI, generally the emphasis is on as good an AI as you can. It's your competency, your ability to solve those problems. That's the thing that matters. And if you can solve it in a more sophisticated, better, more capable way, that's a better AI. That does differ from game AI, which has subtle differences and quite often is operated under quite tight time constraints, which sort of limits the types of activities that can be done. So if we were to define game AI and try to give it a couple of aims, you can see a list of them here. So game AI has to appear intelligent. The player has to look at it and go, "Oh, that's impressive," but yet has also to be beatable. Players play games to win them in the most. So we ultimately want an AI that's nice, is impressive, but is something the player can overcome, can emerge victorious from that. So it's good, but not too good. AI in games have no unintended weaknesses, so things that can be repeatedly exploited. So if we have an AI that has a weakness which the player can sort of use time and time again, that will lower and lessen the overall impact of the AI in the game. It'll appear to be dumb and silly. So we don't want to have AIs that can be repeatedly beaten by using sort of simple strategies or techniques. AI within games, they have to provide an entertaining and engaging experience. That's the whole purpose. We have them within games. They're there to entertain the player, to make the environment more interactive, to challenge the player, to give them something that they can delight in. So it's not about necessarily the efficiency and effectiveness of solving a problem. It's about providing that type of aspect, what it provides to the game. How does it enrich the player's overall experience? Perform within tight CPU and memory constraints. AI will be one of many systems within a game, alongside maybe your physics, your graphics, all of the other things. So you might get a couple, 2-3 milliseconds per update to actually run your AI and to decide what exactly you want to do. Generally, within most commercial games, a reasonably small budget that's set aside for running the AI. It has to be configurable. So it's the type of thing that if we're putting it into games, we want to give the designer and potentially the player the ability to change how well it does. So this can come into things like game balance, come into difficulty levels. And finally, not keep the game from shipping. So sometimes you can have wonderful ideas about, oh, it'd be nice if we did this type of AI, or if we could get that type of behavior emerging. But we always want to be risky about planning to put in sophisticated AI that's maybe a bit untested in a manner that could put at risk the features within the game and potentially hold it back from being shipped. So as you can see, reasonably wide range of different characteristics here. It does differ from academic AI, which is by doing things either cognitively plausibly or as efficiently as possible. There's a lot of things we can rely on within games, and one of the most important things from an AI's point of view is that we, the player, will impart or are inclined to impart a lot of intelligence to the things that we see. We seek out intelligence, we seek out structure, we try to interpret the behaviors that we find. And they're, generally speaking, as I say, most people assess intelligence or the lack thereof and how an object behaves. So fundamentally, how it behaves is understandably, the basis by which we try to assess its intelligence. And something that seems to be complex in terms of its behavior, we will generally try to ascribe to it, it must be complex because it's behaving in a complex way. And there have been studies done where you have an object that behaves in a fixed pattern, except utterly at random, every once in a while, it does something completely different. And that's when it's shown to people will try to interpret that in terms of, look, it's changed direction. It must have changed direction for this complex reason, as opposed to it just changed at random. So we interpret scenes a lot, and you can rely on people then to impart maybe more than is warranted in terms of the behavior of objects. Give me an example of this. I mean, just in terms of how much we like to think that the world and the things that we observe, we simply observe it. We don't change it. We don't manipulate it. But an awful lot of what we do observe is based on our interpretation of it. What's on the screen is probably my favorite visual illusion, that the square A and the square B that you can see on the grid, square A, we'll perceive that to have a dark grey color, square B, a light grey color. The reality is that the colours within those squares A and B is utterly identical. There's no difference at all, but it's the fact that our brain interprets one as being in a shadow, so it must, according to our brain, have a lighter colour because the shadow is casting over it. So we see that then as being lighter than the other square. In reality, if you look at the pixels, identical, utterly identical. So, practical definition of AI. This is the thing that's important for us. Game AI is anything that contributes to the perceived intelligence of an entity. It's all about perception, regardless of what's under the hood. So we don't really care how it's done within a game. Well, we do. We want it to be fast, efficient, configurable, all of those types of things. But if it conveys the impression of being intelligence, then that's job done in terms of game AI. You can sort of raise a set of questions in terms of, well, what constitutes AI? So you could ask, does a single if statement, does that constitute AI? What about scripted behavior? If a player character, or non-player character rather, selects which animation to play from a series of them, does that constitute AI? What about pathfinding within an environment? Do they have to find a path from point A to point B? Or what about games where you automatically create a new random level, but you try to balance things and have it sort of nicely designed and so on? So in terms of these things here, an if statement seems to be a little bit too simple, not sufficiently grand to constitute AI. Scripted behavior, so that's just going through one step after another step after another step. Now, we said if it's perceived, if it gives the appearance then to the player, then it would constitute game AI, and it probably would in that case. But if the player keeps saying it a lot of times, then it's going to sort of lose its impact. An NPC selecting which animation to play. Even if we use there are a series of if statements, we sort of assume the combination of deciding what is the appropriate animation. That seems to be, yes, that's game AI. Pathfinding. Finding location from point A to point B, again, that comes across as being AI as well. The thing at the bottom about automatically generating environment, that's probably the most complex bit. And that does tie into a lot of complex human thinking about how you design an environment, make it interesting, make it balanced, all of those different aspects. So that actually would be a sophisticated, challenging AI to the capable of doing that, but we wouldn't define it as game AI, because there we're talking about really behaviors of entities within games. Just as an aside, because there are 101 interesting thought experiments about AI itself. So Cyril's Chinese room argument is one of the more fundamental, more classical examples, is where you have a system, in this case it's a room, where users, or the person who's interacting with the room, who's assumed to be a native Chinese speaker, comes along and sort of pushes in words, phrases, questions, if you like, in one side. And the person inside it can look it up, can see a set of symbols, and has a big book that says that if you see this symbol, then this is the output symbol that you provide. So effectively, the person, if you like, within this is just sort of looking at symbols, consulting a rule book, and then following, if you see this, do that, following the instruction on the other side. And the output then goes out to the other person. And so it also raises the question that if the person who is interacting with the system, if they ask questions, sensible questions, and they get sensible, meaningful answers back, they are likely to perceive that system as being intelligent. I can ask it things and it responds to me in a way that I think, oh, it understands what I'm asking. And Cyril then asks, okay, well, is that an intelligent system? And which part of it is intelligent? And it gets into a lot of fundamental questions about what intelligence means. At what point does things like consciousness or emergence come out of that thing, if we think of that as a conscience system, all of those different types of things. There's lots of interesting ways you can sort of ponder and think about AI. So within games then, within sort of proper commercial titles, quite often you have AI, you'll have an AI engine within your game. For simple games, the types of things that we're doing, AI tends to be bespoke. That you have a game object, and as update method, you stick in whatever it does, and then you embed it, your AI within that. More sophisticated games, or if you're developing a lot of games, you might then want to have a set of libraries that embodies your AI activities within it, or even push it all the way up to having a fancy AI engine, in the same way you can have a physics engine. So only an aside, type of things that we're doing for our games, and if you want to put it in, brilliant, but you don't particularly have to. But we show it here because it gives you a bit of an illustration of the structure and some of the things that the game AI will have to deal with. So generally, we can group game AI into 3 different categories. It's like a hierarchy of categories. From sort of higher level, strategic and tactical forms of AI, down to lower level, sort of basic movement forms of AI. And in between, you can have some things about individual decision making and so on. For an AI engine, if we're operating within a structure where we have, let's say, 20 milliseconds to do everything, we might have a budget of 2-3 milliseconds to run all of our AI. So AI engine generally needs some idea to be able to execute its AI in a defined period. Or for activities, planning activities that take a long period of time, to do a little bit each frame, and then over maybe the period of 8, 9, 10, whatever number of frames, to build up results as it calculates them. AI generally works on characters. It'll need some information about the game world, so it has to have some way of accessing that world. And has to have some output, and the output from AI generally is a request to a character to move here, to accelerate in that direction, to play that animation, to do different things. So again, our AI engine has to link in by way of providing an output for the AI to have some effect. So we'll have a look at each of these 3 bits. Now really within this course, we'll spend most of our time looking at movement AI. So movement AI is the bottom of our hierarchy, contains a range of algorithms that make decisions about motion. So this can be, how do you move around another obstacle? It can be, how do you find a path from point A to point B? All about basic movement through an environment. And we'll spend quite a lot of time looking at different algorithms in that space. Next level up, we have decision making. And that gets into the notion that a character often will have several different activities or actions that they can choose to do. They may want to move in a certain direction, they may want to jump, they may want to use an ability or an item or something like that. And decision-making AI operates at the level of an individual and says, at this point in time, what's the best action for that character, that entity to undertake? And again, we'll look at a number of forms of decision-making AI. At the top level, we have strategic or tactical AI as well. And that is generally forms of AI that operate on several entities or operate at a large holistic planning scale. So it's not about the here and now, it's about thinking about the broad situation you're in, thinking about your strategies, your plans, what are your long-term goals, how are you going to try to meet those long-term goals through individual actions at a point in time. So that's the highest level. We'll look at a few things here, but it's going to be very much sort of incidental, by way of giving you a bit of a feeling, but not really much more about that. So just to end this lecture off, we'll quickly go through a range of common 2D game genres, and just to identify some of the common forms, not necessary forms, but common forms of AI you would have within those genres. And here we'll classify, we'll group AI into a couple of different categories. We'll introduce the notion of perception, that in some games, characters may have a sort of a knowledge of the whole level and it may be obvious and instant to them. In other games, it's going to be important to say, well, what can that character see and what can't they see? And they can only reason and make decisions on other objects that they can see. So this kind of comes like the idea of stealth games, or ones where visibility, real-time strategy games and things like that. Alongside that, we'll look at steering. We'll mention which games require or put a large emphasis on steering behaviors, basic movement. This is not about planning a route from A to B. This is about how do you navigate or steer around or avoid hitting other obstacles. Action. So this is games that put a lot of emphasis on deciding at a point in time what is the best action for me to take at that point from a set of available actions. Pathfinding. This is a bit more on the higher level. Movement is where you have to plan a route from A to B and then follow that route over a period of time. And then games, 2D games that put a lot of emphasis on decision making, which is thinking about, okay, I have a list of actions, I need to have some basis in which I can decide what is the appropriate action. That generally involves thinking ahead or trying to reason ahead. So the first game we're having a look at is side-on or top-down shooter. So generally speaking, within these types of games, perception-related AI can be important. This is working out what objects are maybe near me, working out if the player has shot a projectile in my direction and I'm trying to move, working out where the player is. So having an awareness of your surroundings within that level. Steering, great emphasis in steering in these in terms of how do you move about, how do you avoid, how do you track the player, how do you try to avoid projectiles coming towards you. And a little bit about firing, so in terms of if you are going to fire and you want to try to hit the player, then it's working out where they're heading to and aiming towards that position, a bit about prediction. So if you did want to put AI within a top-down side-on shooter, that's the type of AI you could put in. Little aside in this, not all top-down side-on shooters actually need any AI. Quite often they operate on the basis of having enemies appear in waves, and those waves move about in sort of predefined patterns. And that is the thing then that presents the challenge to the player. So if you're doing this type of game, don't feel compelled that you need to put AI in. But if you do want to put AI in, then that's the type of AI that fits reasonably nicely within it. Next genre is driving games, so top-down racers. And this one, perception, so working out where the other cars are, working out if you're coming up to a sharp corner, those types of things. Obviously, steering behaviors in terms of being able to have a car that notionally has a simple physics model and to be able to drive it, to accelerate, to turn it so that it follows a track and generally speaking stays on the track. Potentially, you're going to push it out a little bit in terms of decision making about deciding when is an appropriate point to overtake, or when's an appropriate point to try to avoid a collision, or who avoids it, things like that. Next genre is our traditional platformer. So within platformers, you might have a bit of perception where the AI character wants to work out, okay, where's the player relative to me? Is the player within range? Potentially a bit of steering if it's, say, for example, a flying creature and it wants to try to head towards the player. Potentially a bit of aiming. So if you have another character that can throw things, well, how do they throw it so that it hits or nearly hits the player? And again, aside in platform games, is that platform games don't really need strong AI. Quite often they work on having simple AI or predictable forms of motion for the characters. And the real challenge in the player faces in terms of how they do their timing and their movement to get around the obstacles and the challenges they're faced. Real-time strategy games and turn-based strategy games, group both of them together. These generally are quite rich in terms of AI. They can have quite a good perception model, so there may be line of sight tests, it can be height tests, it can be fog of war. All of these types of things come into the visibility of what the AI or the player is aware of. Steering, generally not such a massive thing, but it depends how you have characters maybe moving from one cell to another cell, maybe a little bit. Pathfinding tends to be important in terms of longer term route planning. And obviously, if you're in this type of game, then the whole tactical and strategic side comes into it by way of how the overall game is played out. And aside here that real-time games and turn-based games, they're really the same. Real-time games, they just operate under additional constraint that they can't spend 5 seconds necessarily sort of pause thinking about their next move. They generally have to be a bit more action-based. Next one up, we have 2D beaters, beat 'em up style games. And this generally is decision making, that's the key thing. So characters will have a pool of decisions. They can move to the left, they can block, they can jump, and it's deciding at what point, this point in time, what's the appropriate decision to take. And for this style of game, one of the things about AI is you can get into adaptive AI that learns, it tries to change, that sort of adapts to the player. And this actually is a good genre for trying to put that in. Though I wouldn't necessarily suggest trying to do it as part of this project if you're doing a beat 'em up style game. Sports games is the next one. So sports ones, you have quite a lot of steering behavior in terms of avoiding other obstacles, tracking other obstacles, moving about within an environment. Decision making is quite important in terms of deciding how it is you're playing the game, what is your strategy, your tactics at this point in time. So that can be quite a rich one, similar to a real-time strategy game. The side in this is that for sport AI, there generally is quite a large volume of expertise that the people have codified on that sport in terms of how it should be played or how it can be played well, which is helpful to the AI designer for doing games. But on the flip side of things, the players have, generally speaking, high expectations that it will play well. So there's a reasonably high bar put in sports games. So takeaways, the only one here is that if you're thinking about AI, artificial intelligence is a very broad area within computing, has lots and lots of really important applications. It's important within games as well. And really it's about bringing games to life in a way that will challenge and make it enjoyable for the player. We've seen there's quite a wide range of different techniques that you can use for doing this here, and we'll look at particularly at the lower level stuff in terms of movement, a little bit about decision making, and just really an overview of some of the tactical or strategic forms of analysis.